Hi guys, welcome back to ramanujan.math.circle, and today we'll be covering our second lesson, which is on functions. Functions is a really important part, I think, in algebra, especially in AMC, which is really prevalent in various different forms. It could be as simple as, a simple operator that we have, like addition, subtraction between two numbers. Or it could be as complicated as some things that we will cover later, some special functions. And also there's things that we'll cover in later lessons, like polynomials that are, at the end of the day, functions. So without further ado, let's get into functions. Okay, so basically functions at its core are just mappings from one set to another set. And the way you can visualize this is, let's say there's like a bag and there are things in it. And there's this nice machine, which I'm going to call F. And there are stars that come out of it. So in this case, our function maps these dots to stars. And it's nothing special. There's no kind of mathematical notation to it. The notion is that it maps one set to another set. So it could be something as simple as mapping 1, 2, 3 to the set 5, 9, 10. And completely random. There doesn't seem to be any sort of rule. And you're just mapping them one by one from term to term. And I think that really helps with understanding that functions is not just math simple notation like we see it normally as like fx or gx. But often, yes, that is the way we represent it. And so let's go into that a little bit. So here we have something like f of x is equal to 2x. And obviously the way I'm reading it out is this thing, right? Of, and then whatever this thing is. So f of x. And what basically this means is that f is represented in terms of x in some way, like any kind of thing. In this case, we're going to look at particularly 2x, which all it does is it takes the next value and it multiplies it by 2. It's as simple as that. There's no big deal about it. And so oftentimes a lot of our like lines, for example, so this is fx equal to 2x. So we could just set that as y equal to 2x and we graph our line. And oftentimes this graphing can be really useful and enabling in solving function problems. So let's look at a simple function from an AMC question. So it basically says define x circle cross y is equal to x cubed minus y. What is this expression? And so the way we're going to go about it is obviously use PEMDAS. So we're going to go inside first, inside the parentheses. So we find that this is equal to h cubed minus h, right? And then we replace the parentheses, the stuff in the parentheses with h cubed minus h. And now all we do is just get that this is h cubed minus h, which is h cubed minus h cubed plus h, which is equal to h, because this cancels out. And the way I get this to work is that I look at x circle cross y is equal to x cubed minus y. And what I do is just make a mapping. So I just say, okay, x in this case is h, and y in this case is h as well. So I do x cubed, which is basically h cubed right here, and then minus y, and y is also h in this case, so minus y. And for example, in this case, I said, okay, x is equal to h, y is equal to h cubed minus h. So I say, okay, h cubed, and then minus h cubed minus h. So that's basically how I work it out. I make a sort of mapping. And I think at the beginning, when you're trying to do problems and make sure they're right, it's nice to write down a small thing like that here, so you know that you're doing things right. You're replacing and substituting the right way. Okay. So yeah, we got a right answer right here, h, and that's the way to approach this question. So now we'll go into something a little more important in terms of like, if there's no domain and range, there is no functions because they both go so hand in hand. And I think definitely there can be some ways that domain and range can come in handy, especially when you're determining whether some solutions work or not. So right off the bat, let's think about this. You know how we have a lot of rules like, oh yeah, you can't square root a negative number. That's not allowed. You can't, oh well, okay, a square of something can't be negative. That's a rule. There's stuff like, there's a lot of stuff, rules like that. And obviously you can't divide by 0. That's not allowed. So these rules come in handy when you're figuring out domain and range. And so let's take a quick domain problem. We're going to set f of x is equal to x plus 3 over x squared. And now we're trying to find the domain. Way we're going to go about this is we're going to use something that we're going to figure out something we're not allowed to do with this. And what we're not allowed to do with this is plug in x equal to 0, because then you'd be dividing by 0, and obviously you can't divide by 0. So that means that, but every other value seems to work, to me at least. So what we can do is we find our domain, and that's equal to, so it's r minus 0. And what r is all the real numbers, all real numbers. And this just represents the set of integer 0, right? Set that has a set basically with 0 in it. And so all that is that, because anything, all this is anything but 0 that is a real number works as an x value for this function. And so that's basically what a domain is it's basically the set of x values, or the inputs that you can put in a function. The range is a little different. The range has to deal with the y values. So it's less of the x values, more of the y values. And what it is how far can it go? Like if you have here to here, how far can it go? So the way we're going to work it out is we're going to take an example, and we're going to call this g of x. And we're going to say minus 20x plus 500. We're going to complete the square. And for those of you that don't know how to complete the square, just follow along with me. And so we'll start out with this identity that a plus b squared is equal to a plus 2ab plus b squared. So now what we're going to do is we're going to use that same form here. So we're going to set a is equal to x, 2ab is equal to negative 20x, and so we know that b is equal to negative 10 because we know that a is equal to x. So now what we're going to do is we're going to plug this back in, and we're going to obviously b squared, if b is negative 10, then b squared is 100. So then it's plus 100 plus 400, right? Because you're splitting your 500 into 400 and 100. So now you could just write this as x minus 10 squared plus 400. So now you use this rule that a square of a number has to always greater than or equal to 0. So then you have that x minus 10 squared always has to be greater than or equal to 0. And what that means is that adding 400 on both sides, x minus 10 squared plus 400 is greater than or equal to 400. And then this gives us the range, because what that means is just anything greater than or equal to 400 works. So then your y just has to be greater than or equal to 400, and you're done. That's your range. So yeah, that's how domain and range really works. And let's look at another tiny example for this, just like one function that we're going to talk about. And in this case, we're going to use the rule that you can't square root a negative number. This is a big no-no. So the way we know this is that, okay, so if you can't square root a negative number, then x squared minus 9 has to be greater than or equal to 0. And what that means is that x squared is greater than or equal to 9, adding 9 on both sides. So now what you do is you say, okay, well, let's take a number line. Let's draw a number line real quick. I'm going to put 0 here. So we know that square root of 9 is 3 or negative 3. So make sure you remember the negative sign. So negative 3 or 3. And what we could do as of now, just test out which values we think we work. Okay, so definitely 3 and negative 3 are going to work. Does 0 work? Let's try that. So does 0 squared greater than or equal to 9? No, so that doesn't work. But how about like 5, for example? Yeah, 5 definitely works because 5 squared is greater than 25. 5 squared 25 is greater than 9. And something like negative 5 also works because negative 5 squared is 25 as well, and that's greater than 9. So it's basically the stuff on the outside. So what we get is that the range is, the domain is x is greater than or equal to 3 and x is less than or equal to negative 3. So that's our domain. And then our range is something different because in this case, just plug in anything and you get all the real numbers. And so that's why our range is, the only thing in our range that matters here is that the square root of a number generally, it only outputs positive integer, positive, or actually I should say and plus 0, right? So square root of x has to be greater than or equal to 0. And as a result, we get that the range is just y is greater than or equal to 0. So yeah, that's basically about domain and range at its simplest. And now let's move on to some basic things about functions, just a little bit, following on from domain and range. So a real function is basically a function whose range is in the real numbers, and usually whose domain is also a subset of the real numbers. And what a subset means is that it belongs to the real numbers. Like, so if it's a small part of a real number, so it's like a small part, and basically it could be something like, okay, this is a subset of real numbers because it's a part of the real number still, because all it is it's missing 0. That's it. So that's what it is. And a real function is a function whose range is in the real numbers. So again, that's the same idea. And generally when we look for domain and range, we look for the real values that work. Unless, of course, we're dealing with complex numbers, which we will talk about a little later. Also, functions are very commonly graphed. Like I showed you in an earlier slide where we had this drawing, we often graph functions. And the only way we know it's a function is if it passes this thing called a vertical line test. And what it basically means is when you draw your function out, for example, I'm going to draw this. If you draw any sort of vertical line through it, it should cut the function or the graph at only 1 point. And in this case, it's all 1 point each. Okay. But if we had something like this, for example, this would have a problem because if we draw a line through, then it cuts at 2 places. And that's not okay. So then this is not a function. So that's how we determine whether a function is a function or not, because or a relation is a function or not through a vertical line test. If it's not a function, then we call it a relation, like I just stated. So yeah, these can be really useful when it comes to some AMC problems when they talk about which of the following does not work, or which of the following does not belong as a function. And all you have to do is your vertical line test and figure it out. And this could be at the earlier section of AMC. This could also tie into something another question has, where you figure out multiple solutions to a question, and you have to narrow down on certain answers. And you can eliminate some of them because they don't match the criteria in the function. So, for example, if I solved something and I got x squared minus 9, in this case for this function is equal to -5, right? I mean, by looking at it, it looks fine because all we would do is, x squared is equal to 4, and that's totally possible, right? But in this case, you're square rooting x squared minus 9. So can you square a -5? No, in terms of real numbers. So that's why it can be really useful to detect domain and range in your problems. So that leaves us in with looking, going into exponents and radicals in the next section.